A new rogue object has been found hurtling through our solar system directly in between interstellar object 3I Atlas and Earth. This is C2025 V1 Borisov.
A new mystery begins when a strange object suddenly appears in the narrow space between Earth and 3I Atlas, turning a quiet region of the sky into something far more unsettling. Astronomers had just finished tracking 3I Atlas after its close pass by the Sun, and many were confused by its bright glow and the absence of a clear tail. Then, C/2025, V1 Borisov entered the picture, discovered by the same observer who found the second interstellar object in history. Its timing and position were so unusual that experts immediately questioned whether this was only a rare comet or something sent from the visitor itself. So what exactly did we see rising between us and 3I Atlas? "3I Atlas broke the rules long before the new rogue object appeared, and this is the reason astronomers are watching every movement around it with such intense focus. The object is only the third confirmed interstellar visitor in human history, yet its behavior has challenged ideas that scientists once believed were stable. Its path through the solar system does not match the smooth curves usually produced by natural comets, and its approach angle is much steeper than expected for something drifting from deep space. These details matter because unusual motion often reveals unusual origins, so experts quickly realize that 3I Atlas demands a different way of thinking. The lack of a clear tail is the first major sign that 3I Atlas does not act like a normal comet, especially since it passed very close to the Sun during its perihelion. Most comets heat up when sunlight reaches their surface, and the trapped ice turns into gas that escapes into space, forming a bright tail. This simple process is why tails are considered one of the most predictable features in comet science. However, 3I Atlas kept moving without releasing visible streams of gas, and its coma stayed tight and smooth even when strong solar radiation hit it directly. This strange silence suggested that its outer layers hold little volatile ice, which means the object may be built from harder materials. The brightness of 3I Atlas became the second puzzle, and it confused many researchers who expected the object to dim after its peak near the Sun. Observations from July to early September matched the basic model for interstellar comets, but everything changed when it suddenly jumped above the predicted light curve. A difference of 1.4 magnitude is not a small step, because each magnitude represents roughly 2.5 times more brightness. This means 3I Atlas was shining more than 3 times stronger than expected. What made this rise even stranger was the fact that it still did not develop a tail while brightening, which is rare for any comet under heavy solar energy. The object behaved as if it was reflecting more sunlight than its true size would normally allow. The third major issue appeared when solar storms reached the region around 3I Atlas. During late October and early November, a group of large sunspots rotated toward Earth and the incoming objects, producing strong geomagnetic activity rated in the G3 and G4 ranges. These storms usually create intense solar wind that hits any nearby comet with enough force to blow dust and gas into space. Yet even under this pressure, 3I Atlas continued its journey without a dramatic reaction. It showed only a small amount of non-gravitational acceleration, and later calculations revealed that this force was weaker than originally estimated. This meant the Sun's energy did not produce the kind of movement expected from an icy body. Once again, it pointed toward a structure made of rock, metal, or dense carbon instead of frozen gas. All these unusual patterns raise an important question for astronomers, because when one object already behaves in a way that defies basic expectations, anything that appears close to it becomes harder to ignore. So if 3i Atlas already breaks so many rules, what does that mean for the new object moving directly between it and Earth? The discovery of C/2025 V1 Borisov began quietly, yet its timing and location immediately turned it into one of the most discussed objects of the year. Astronomers first detected it in early November while reviewing a set of routine sky images, and at that moment it did not even have an official name. It appeared only as a technical label, GB000810, which usually means the object is new, faint, and still waiting for follow-up confirmation. Even so, the first observers recognized that something about its path deserved attention, because new objects rarely appear in a region already monitored for interstellar activity. This early clue made researchers look closer at its motion, and that decision changed the direction of the entire investigation. The basic trajectory of C/2025 V1 Borisov is unusual because it rises from below the ecliptic plane and then cuts upward in a sharp line, eventually moving above the paths of Earth and 3i Atlas. Many comets enter the solar system from odd angles, but this object approached in a way that made its future alignment impossible to ignore. When astronomers loaded its coordinates into 3D simulation tools, they saw that by mid-November, the object would almost line up with Earth and 3i Atlas from our point of view. The fact that this alignment would happen so soon after the discovery created a sense of urgency, because close alignments often make measurements easier while raising new questions about shared space. The moment of perihelion provided another important detail for tracking the object. Its closest pass by the Sun is set for November 16th, and this date arrived only days after its first confirmed detection. Objects discovered so late are usually small, dim, or hidden behind solar glare, yet this one seemed to appear only after it had already moved into a sensitive zone. Such timing made astronomers wonder if the object had been too faint to see earlier, or if it had accelerated into view when Earth-based telescopes were not expecting activity in that region. The possibility of a late appearance added to the growing interest surrounding its origins. Another crucial point is how the object's appearance near 3i Atlas changed the mood in the scientific community. When two unusual objects occupy nearly the same field of the sky, observers naturally check whether they share related traits. For C/2025 V1 Borisov, the most striking detail was how it entered the exact corridor between Earth and 3i Atlas soon after the interstellar visitor passed its perihelion. This narrow timing felt too sharp to dismiss as random, especially for astronomers who were already watching the area for new motion. The object's quiet arrival created an atmosphere of mystery, because unpredictable behavior often suggests fresh physics or simply incomplete data. The final question that emerged from its discovery concerns whether this object is an unrelated comet or something following a coordinated path. Most scientists believe it is part of a natural pattern, yet the combination of late visibility, rising trajectory, and near-perfect alignment gave many people a reason to pause. So if the discovery alone created this much tension, what deeper mysteries would the object reveal once astronomers examined its structure? The most striking feature of C/2025 V1 Borisov is its lack of a visible tail, and this single detail has pushed the object into the center of scientific debate. A comet is expected to release gas and dust when sunlight heats its surface, and this reaction normally creates a bright tail that stretches behind the nucleus. This process is so common that it forms the basic rule for identifying comets in the sky. However, the new object appears to ignore this rule completely, because most early observations show nothing more than a small coma with no clear trail of material. This unusual silence from the comet's surface immediately set it apart from many other objects passing through the same region. Reports from observers provided even more confusion because the data did not match in any predictable pattern. There were 10 independent records describing the coma and tail, and only 2 of them claimed to see any form of a tail at all. Even these 2 reports did not agree with each other. One observer measured a faint extension of about 50 arcseconds, while the other suggested a much longer feature of over 70 arcseconds. Such a large difference makes it difficult to confirm whether the tail is real or simply an illusion caused by the brightness of nearby stars or camera settings. When 8 other observers reported no tail whatsoever, the uncertainty deepened. As a result, astronomers began to treat the object as a rare case that needed more detailed follow-up. The lack of a tail becomes even more meaningful when compared to 3I Atlas, because both objects share the same strange behavior. 3I Atlas has a bright coma but no clear stream of dust, and C/2025 V1 Borisov seems to follow that same pattern. This parallel becomes harder to ignore when placed next to K1 Atlas, another comet in the area that displays a golden tail stretching across the sky. The contrast between these objects helps scientists highlight the mystery, because it proves that the conditions near the Sun are strong enough to generate normal comet behavior. If K1 Atlas reacts correctly, then the 2 tailless objects must be studied much more carefully. Another important detail is how the surface of C/2025 V1 Borisov reflects light. Even with no tail, the object's coma appears stable and tightly shaped, as if nothing is escaping from its nucleus. Some scientists believe this might suggest a composition dominated by rock or carbon rather than ice, because harder materials do not sublimate in sunlight the same way frozen gas does. This theory also matches the clues found on 3I Atlas, which led many experts to consider whether both objects may come from similar environments. While the evidence is not complete, patterns like this create a foundation for future research. The fact that 2 objects so close together display the same anomaly raises a broader question for astronomers. When 2 visitors ignore the normal rules for comet activity, their shared silence becomes more important than any individual detail. So if their surfaces refuse to act like traditional comets, what does that reveal about the true material hiding inside each object? The brightness of 3I Atlas has become one of the most important clues in understanding its true nature, because the object refuses to follow the simple pattern expected from a comet moving through sunlight. Astronomers rely on light curves to predict how a comet should appear at different distances from the Sun, and these curves normally show a smooth rise and fall as the object heats up and then cools. From July to early September, 3I Atlas matched this model closely, which made observers believe that nothing unusual was happening. However, everything changed when new measurements revealed that the object had jumped far above the expected brightness line. This sudden rise was strong enough to create confusion, and it pushed experts to search for a new explanation. The scale of the brightness jump shows how strange the object truly is. The most recent measurements placed it at magnitude 9.8, while the predicted value for that same time period was around 11.2. A difference of 1.4 magnitude may seem small, but each step on the scale represents roughly 2.5 times more light. This means 3I Atlas became more than 3 times brighter than scientists expected, which is not something a normal comet does without a major release of gas or dust. What made the puzzle even deeper was the fact that 3I Atlas did not develop a tail during this brightening event, so the increase did not come from new material escaping the surface. Instead, the object acted as if its entire body suddenly became more reflective. Another surprising detail is how this brightness behaved after the object passed through intense sunlight. Comets usually release even more gas when they approach perihelion, because the heat is strongest at that moment. This release creates a larger coma, and the tail becomes easier to see. Yet 3I Atlas kept its coma small and smooth, and no extended tail emerged even when the sun was close enough to trigger powerful reactions. The object also survived repeated streams of solar wind without showing any dramatic changes. These reactions, or lack of reactions, made scientists think about new possibilities such as a dense outer layer or a surface mixed with unusual minerals that do not respond to heat like frozen gas. The mystery deepens when the object's brightness is compared to its distance. Normally, comets gain brightness quickly as they approach the sun because sunlight reaches more of their surface. In this case, 3I Atlas was farther away than many comets that showed weaker activity, yet it still outshined them. This created a contradiction because brightening without melting suggests a different kind of structure. Some experts think the explanation may involve a high concentration of metallic or carbon-rich material, which reflects sunlight strongly without creating visible outflows. Others argue that the object's spin might expose reflective surfaces at certain angles, although this idea has not been confirmed. These unanswered questions make the brightness puzzle one of the most important topics in the study of 3I Atlas. When a comet shines stronger than predicted while refusing to produce a tail, the rules of comet behavior start to break, which forces astronomers to think beyond traditional models. So if the brightness already challenges everything we expect, how will the object behave when extreme solar storms begin to strike the region around it? Solar storms usually bring dramatic reactions from comets, yet 3I Atlas and the region around it behaved in a way that surprised every observatory watching the sky. When a group of powerful sunspots rotated toward Earth in late October, scientists predicted that any nearby comet would respond quickly because strong radiation and fast-moving solar wind normally tear gas and dust from a comet's surface. These conditions create long, bright tails that stretch across space, and the effects often become visible within hours. However, 3I Atlas showed almost no response, and this lack of activity made the situation even more mysterious. The storms reached the G3 and G4 levels on the geomagnetic scale, which means the energy hitting the solar system was powerful enough to disturb satellites and affect radio signals across the planet. Under this level of force, most comets lose mass rapidly as their icy layers react to the heat. The process usually produces sudden bursts of light as the nucleus releases trapped gas. Despite this, 3I Atlas continued its movement without forming a tail or changing the shape of its coma, and the object maintained the same smooth outline that observers had seen earlier in the month. These details suggested that the comet was built from something stronger than ice because volatile material would not survive such intense sunlight. NASA's updated calculations added even more confusion when they showed that the non-gravitational acceleration of 3I Atlas was lower than the early models suggested. Comets often drift slightly from their predicted paths because gas escaping from their surfaces pushes them in new directions. This drifting pattern is a key sign of melting, but the interstellar object barely shifted at all. The reduced acceleration meant that solar radiation did not produce the expected push, reinforcing the idea that most of the object's mass does not react to heat in the way frozen gas does. This led some researchers to discuss the possibility of a dense or metallic outer layer that shields the inner material from melting. The arrival of C/2025 V1 Borisov added another layer to the mystery, because the new object also moved through the region without displaying a strong reaction to the storms. If both objects remain stable during periods of extreme solar energy, then their shared behavior becomes harder to explain with normal comet science. The storms provided the perfect environment for revealing hidden traits, yet the objects stayed unusually quiet. For astronomers, silence during chaos can be more revealing than any bright tail or sudden flare. These patterns force scientists to think more deeply about the material and structure of both visitors, because their refusal to react to the sun may be the key to understanding where they came from. So if even the strongest storms fail to change their behavior, what will happen when the objects move into a region crowded with other unusual bodies in the night sky? The night sky became even more intriguing when astronomers noticed that three unusual objects were gathering in the same region, and this unexpected arrangement raised new questions about their connection. 3I Atlas and C, 2025. V1 Borisov both appeared inside the boundaries of the Virgo constellation, while the bright comet K1 Atlas was found in the neighboring constellation of Leo. These locations may seem ordinary at first, yet the timing and spacing between the objects created a visual pattern that observers could not ignore. When several bodies with rare behavior gather in a narrow window of the sky, scientists pay closer attention because shared space can reveal hidden relationships. Stellarium and other sky simulation programs helped researchers study this unusual formation, and the results surprised many people who followed the event. When the timeline was set around November 6th and 7th, the models showed that 3I Atlas and C/2025 V1 Borisov were moving through nearly the same field of view. The objects appeared close enough that amateur astronomers could capture them together during early morning observations, especially when the atmosphere was clear enough to reveal dim objects. These simulations also showed that K1 Atlas remained nearby, shining with a golden tail that stretched across several degrees of the sky. This bright contrast made the region stand out even more, since the other two objects refused to produce tails despite strong sunlight. The visual alignment created a sense that something larger was unfolding in the background. Astronomers often watch comet clusters because close groupings can help reveal differences in composition or behavior. In this case, the behavior of K1 Atlas demonstrated how a normal comet should react as it approached the sun. Its clear, glowing tail proved that the environment contained enough energy to trigger typical comet activity. When compared to this normal response, the silence of 3I Atlas and C/2025 V1 Borisov became even more important because it confirmed that their unusual behavior was not caused by lack of sunlight or weak solar wind. The three-object arrangement turned the Virgo and Leo region into a natural laboratory where differences were easier to study than ever before. Another important detail is how the alignment helped observers check for changes in brightness or motion. When objects pass through the same field, small variations become easier to detect because they can be compared directly. For example, sudden brightening in 3I Atlas could be contrasted with the stable glow of K1 Atlas, and any movement in C/2025 V1 Borisov could be measured against its background stars. This simple advantage of grouped observation made the event even more valuable for scientists who were trying to understand why the interstellar visitor acted so strangely. This rare arrangement of three different objects in the same region of the sky encouraged astronomers to consider whether these alignments were truly random or if they hinted at something deeper. So if the sky itself is gathering these objects into one narrow window, What might we discover when we look at the images taken during this strange moment? The search for clear images became one of the biggest frustrations in this investigation, because every major source of data delivered results that raised even more questions. China was the first to release new material when the Tianwen probe sent back photos of 3I Atlas taken from Mars orbit. Yet the images were so pixelated that almost no structural detail could be confirmed. The blurry outline showed a faint coma, but nothing that could help scientists understand why the object behaves so differently from normal comets. For many viewers, these low-resolution frames felt like pieces of a puzzle that had been washed out before anyone could study them. Ground-based observatories also tried to capture sharper images, and a Spanish telescope produced one of the clearest results available in early November. Although the photograph showed the coma of 3I Atlas, it still did not reveal a convincing tail or any sign of material escaping from the nucleus. The object appeared strangely smooth and stable, even after passing through strong sunlight and heavy solar wind. This lack of definition made it harder to confirm whether the interstellar visitor had changed after its perihelion, because the details were simply too fine for the equipment to observe with certainty. NASA's expected release of high-resolution HiRISE images added another layer of suspense, since many people believed those pictures could finally provide an accurate look at the structure and motion of 3I Atlas. However, political delays and the government shutdown slowed the entire process, leaving researchers waiting without a clear timeline. NASA stated that the imagery would be shared once normal operations resumed, yet the long pause created a sense of emptiness around an object that demanded attention. Scientists depend on consistent visual data to track how a comet evolves, but the lack of images meant that many parts of the story remained incomplete. Even though no conspiracy was officially suggested, the combination of blurry photos, delayed releases, and limited access created a feeling that important information was missing at the very moment when the world needed clarity. An interstellar object only appears once in a lifetime, and yet humanity was forced to study it through imperfect snapshots and incomplete updates. For astronomers, the situation was like trying to examine a rare animal in the dark, guided only by shadows and guesses. This growing uncertainty makes one question what the next set of images will reveal when they finally arrive. So if the clearest data has been delayed again and again, what might appear when the missing pictures finally come into view? The mystery deepens when two objects with no clear tails move through the same region, and their behavior challenges everything scientists expect from normal comets. 3I Atlas shines brighter than predicted, while C/2025 V1 Borisov appears in the exact space between it and Earth, creating a rare situation that feels more like a warning test than coincidence. These patterns force us to consider whether we are watching two strange comets or something designed to approach quietly. The answer may change how we see visitors from beyond our solar system. Do you think these objects are probes, comets, or something else entirely? Comment below and subscribe for more discoveries.